Hi everyone, my name is Adrian from 3Flatline, and today I'm going to walk you through the Dixie platform to show how easy it is. We'll run through a full analysis process and then take a look at one of the result files, leaving the rest for later videos. I've just started the CLI and passed in my credentials for authentication. I checked to make sure I have a clean environment on the server, and it looks like we have no prior run tasks to clog up our workflow. I'll copy the path from our test files folder that we'll be submitting, and then pass that to the create task command. As you can see, there are different types of files in this folder with an executable, some C files, and a binary ninja file. The CLI created tasks for all the supported files and skipped the rest. After we submit the jobs, we'll just take a quick check at their current status, and it looks like the server has started processing a couple already. While we wait, let's quickly take a look at one of the test files, a deliberately vulnerable C file. Scrolling through, we can see a number of comments indicating types of vulnerable code snippets. As I highlight the individual comments, see if you can see what is actually vulnerable with the code that follows it. All right, let's check the status again. And it looks like in the time it took to scroll through and read the comments, Dixie was able to analyze the rest of our testing files, consisting of the same code we just looked at. That file, but compiled and disassembled, a firmware driver, and a Thunderbolt driver. Since everything is complete, let's list the results, but also download them as Markdown. Then we can delete the tasks from the database. The source files are deleted immediately upon completion of their analysis, so deleting the results from the server removes any reference to, say, my company's submitted code. Now let's take a look at some of the results. I've looked through the downloaded file until we see a specific file name that we're looking for, the same one we looked at earlier. I've also opened up that source file to the right. Looking at the first bug, it indicates the function processImage has a potential buffer overflow. So let's find that function. When we looked through this file the first time, we were looking for the comments and didn't really notice an obvious issue right at the very beginning, that this function takes a buffer and a size as arguments and then casts an image struct onto that buffer. But it does no checks for the size that the buffer can actually fit an image struct. What happens if an image struct doesn't actually fit? This was actually unplanned when we first used this file, but is of course a pleasant surprise to know that Dixie doesn't need you to comment potential bugs in code. Looking down further, we can also see an integer overflow. If the sum of the width and height are greater than the number held in an integer, an overflow will occur. Next up, a potential heap overflow, because there's no check that the size of the data will fit into the allocated buffer. For the rest, I'll fast forward. Suffice to say that the annotated bugs were found. But this is just a simple example. Can you imagine throwing a large directory of files or an entire codebase at this? If you could have an easily readable report listing every potential bug and the file that it was contained in, that sounds pretty helpful. If you think so, check us out at 3flatline.ai or email for a more in-depth demo, or maybe even to try it out yourself at info@3flatline.ai.